Good afternoon and welcome to Agrifood Conversations brought to you by iSelect, the Van Trump Report, the Yield Lab Institute, and Family Farms Group. My name is Luke Wazenchuk, an analyst on the iSelect team, and I'm excited to welcome you all to today's call. On today's Agrifood Conversations call, we are joined by Bobby Levine, CEO of Digestate Organics. Digestate Organics is working to reduce the cost and environmental impact of waste disposal through on-site waste treatment and bioenergy production. It's focused on the conversion of organic wastes, such as manure, digestate, food and beverage manufacturing wastes, and other high-strength wastewaters, into clean water, concentrated co-products, and, when possible, renewable energy. It does this by filtering and treating difficult waste streams to help customers reduce wastewater disposal costs, reclaim clean water for reuse, and produce valuable co-products. Each of you knows companies are more likely to succeed with the right network of customers, talent, investors, and advisors. We've invited you to this call because you are some of the smartest, most talented people in Digestate Organics market. You are potential customers for Digestate Organics products and services. You've built and sold a company like Digestate Organics, or you are a sophisticated business person who understands Digestate Organics market and the challenges it may face. Before we get started, we have a quick poll question to get a better idea of who we have on the call today. Please take a few seconds to answer. A few process comments. We're not soliciting investment. This presentation is to provide information about Digestate Organics products and services to help them find customers, mentors, or other strategic relationships that can help them grow their business. You are all on mute. You can use the chat window to ask a question. After the formal part of the presentation, we will answer as many questions as time allows. This presentation is being recorded and will be available for replay. So without further delay, I'm pleased to introduce Bobby Levine, CEO of Digestate Organics. Take it away, Bobby.
Thanks, Luke. All right, so I appreciate the opportunity to tell you all a little bit about what we do at Digestate Organics. And to do that, I'm going to take you through our core technology offerings, a little bit about our team, and then give you an example of our system installed at a dairy farm in Wisconsin to go over how the technology can work to process manure into high-value organic fertilizers and clean reusable water. So in general, Digestate Organics helps a number of different kind of customers, such as dairy and swine farms, food and beverage manufacturers, and industrial customers like landfills and composters manage their waste more sustainably. And all of these customers tend to have the same set of challenges, even though they are making unique products or in unique markets. They're trying to reduce their disposal costs. They're dealing with ever-tightening regulations. Typically, they face some kind of legal challenge, whether it's to expansion or siting or waste disposal. And they're facing public perception about their waste streams and environmental issues as well in terms of watershed management. You know, we hear a lot about algal blooms today, contamination in the Chesapeake Bay and the Great Lakes. So a challenge that it's pretty universal. Our solutions are on-site systems that transform waste into clean, reusable water, value-added co-products, and when possible, renewable energy. A little bit about our team. I co-founded the company about 7 years ago now. My PhD is in chemical engineering from the University of Michigan. Before that, I studied microbiology at Middlebury College in Vermont. That's where I first got into working with cows and dairy farms that had digesters. My first startup company was an algae technology company where we produced animal feed. So I spent about 8 years producing feed ingredients for animals, and now I spend a lot of time working on the back end of animals, helping manage their manure. Our chief engineer is Ian Charles. He has a long history of experience in clean tech, ran a wind turbine company, a very thoughtful and creative mechanical engineer that does a lot of our design work. And Don Heilman is in charge of business development for the ag sector. A lot of years working in Wisconsin, helping farmers develop solutions for clean water. And I'll just point out too that one of our lead investors is Ceres Partners. They have a large land holding base as well as a venture type fund that invests in companies like ours that are doing unique, sustainable things in the food and beverage space. So we have 4 key technologies. I'm going to really highlight 2 of them today in the interest of time, which is our 2-step reverse osmosis and our stainless steel ultrafilter. But in general, we pride ourselves on developing polymer-free and fully automated solutions. So there are a lot of companies that do try to treat waste with polymers. Those are chemicals that help coagulate solids. Those tend to be expensive. They tend to have some detrimental side effects in the environment. We try to stay away from those and fully automate our system so that they're not a hassle for farmers or others to run. So very briefly, we have a spiral brush screen filter. This is a lower cost filter that can process manure and other wastewaters to remove particles that are larger than typically around 10 microns. So the tightest screen is very effective when you have a high amount of suspended solids, like in a food and beverage wastewater or a manure, and you're just trying to reduce that load. Helps keep dairy lagoons cleaner, helps reduce surcharges that a food and beverage manufacturer might have, and it's relatively cost effective, so we can do very high throughput in a relatively small machine pretty cost effectively. This is a very unique proprietary technology we have called ultrafiltration, which uses stainless steel tubular membranes. And the secret sauce here really is the tubular membrane, its porous structure, and how we can pump the liquid waste we are trying to filter through the inside of the tube. The liquids pass through the wall of the tube while the solids are retained. So when we're filtering manure, this is a very nearly perfect phosphorus filter. So we can remove like 95+% or more of phosphorus, as well as high degrees of fog, which are like fats and oils, as well as all pathogens. So we can create a very clean permeate or filtrate, and then a high solids concentrate. And what's nice about this is stainless steel. It lasts 10 to 15 years. It is a bolted, welded design, so it's very robust. This is a picture of a system that I'll show you more about that's been on a farm for about 3 years. So it's just a very robust filtration technology that is very differentiated from other plastic-based filters that are more commonly replaced. And then finally, I mentioned our 2-step reverse osmosis process. It's really a combination of forward osmosis and reverse osmosis. And forward osmosis involves having the material you're trying to filter on one side of a membrane, and then a saltwater solution on the other side of the membrane. And that saltwater solution is saltier, and it actually draws water through this membrane. And so you can think of it as we're basically pulling the water out of wastewater. That water is then in salt water, and then we use a conventional reverse osmosis system to pull clean water out and recycle the salt. So salt is staying in the loop on one side of a membrane, wastewater is being dewatered on the other. What's really cool about this is that it's very high flux. That means the water filters very quickly. It's very low fouling, which means it doesn't have to be cleaned very often. And it runs at very low pressures and moderate temperatures. So we can pull water out of wastewaters very efficiently in a way that is much less expensive than using an evaporator or using conventional reverse osmosis technology. All right, so that's sort of an overview of the key filtration technologies. The example I want to show you now is particular to dairy manure. It would be a very similar example with swine manure and could also involve other agricultural waste streams or leachates or even food and beverage type wastewater. So on a typical dairy farm, we're working with raw manure or with digested manure. And the first step in the process is some kind of fiber removal step. So typically it's a screw press. There are other technologies, but a screw press is probably the most common. That removes a pile of fiber, which that farmer could use as bedding for his cows or could be composted. And this is a fairly conventional piece of technology, not unique to us, but it's the first step in the process to remove these larger particles. The second part of the process would be the ultrafiltration. And so here we're creating a UF concentrate, which has all of the suspended solids, all the pathogens, all the phosphorus is in that product, which is I call it a high solid slurry, and it can be used as a fertilizer. And the permeate comes out, some people call it tea water. It looks like a filtered beer or a tea water. And this is ideal for irrigation at higher volumes close to a farm. So we've removed the phosphorus. In a lot of cases, that would allow a farmer to place higher volumes per acre of that material on their farms. And it also, is benefited from the fact that it's pathogen-free. It doesn't have solids that can clog irrigation nozzles. So it can be a very nice product to use for direct irrigation. The next step, if a farmer wants to make clean water, is to go through our two-step reverse osmosis system, which will generate a concentrate. It's really an FO concentrate, and then a clean water product that could go through a final step of disinfection before it was reused to, let's say, provide drinking water for cows. If it was just being discharged to a river, we wouldn't need the ultraviolet disinfection. So to kind of break down a little bit of what this looks like in terms of gallons and kind of a mass balance perspective, if 1,000 gallons of raw manure went into a screw press, typically we'll get about 90% of those gallons out as what we call pressate or liquid manure. Those 900 gallons would go into the ultrafilter and split into about 675 gallons of tea water and 225 gallons of concentrate. So that's a 75% recovery in the US. And then if we do the similar 75% recovery in the FORO system, we'd have about 175 gallons of concentrate and 500 gallons of water. So on a raw manure basis or raw digestate basis, we're at about 50% recovery of water. 50% would be recovered as two different fertilizers. The UF concentrate is a high phosphorus fertilizer, and then the FO concentrate is a high ammonia, high potassium fertilizer. And because we haven't introduced any chemicals, these are both organic certified fertilizers, which could be brought to nearby crop farmers or used on the farm itself. Another example I want to point out particular to farms today is leachate. So leachate is any wastewater that typically like rainwater falls on concrete and then is collected on a farm, and some of these larger farms have potentially acres of concrete, and so lots of rainwater is collected. That leachate is relatively dilute from a wastewater perspective, but it still, in many cases, has to be handled just like manure. So it has to be collected in a pit, and then it has to be stored on land, and that can be expensive for the farmer. So he's looking for an option to more cost-effectively handle that. And because that wastewater doesn't have a lot of solids in it, it can go right into the two-step RO. We don't need to do the ultrafilter. We might use a spiral filter if there were lots of suspended particles, but for the most part, we can recover very high volumes as water, and that's pretty unique with our technology. So we can get out 90% of the leachate gallons as clean water at a very low cost point. So it's a nice alternative to farmers storing leachate in manure lagoons. It's actually just collect it and process it, feed that water back to your cows, and then you could just store the concentrate in your manure lagoon. And one point I like to make here is that people who are concerned about nutrient runoff when farmers spread manure know that the thicker the manure is, the less likely it is to run off. So imagine putting water on a field. That's more likely to physically run off a farm field than something that's thick, like imagine like a thick pea soup. So it doesn't make a lot of sense to store leachate, which is basically water, in a manure lagoon because you're just diluting your manure and making it thinner. So we encourage farmers to keep their manure as thick as possible, and the UF concentrate is even thicker, so that's even better, less likely to run off, and then treat your leachate independently with a system like this. All right, so this is now a case study of Majestic Crossing. This is a farm in Sheboygan Falls, Wisconsin that installed our system about 3 years ago. They have 850 cows, and they bed on sawdust. And so the manure is collected by a scrape system. It's screw pressed. It goes through the ultrafilter, it goes through the two-step RO, and then clean water is fed back to the cows. So this is a picture of the screw presses in action. Manure is pumped into the top. Solids fall out the front of the press as a sort of a dry, crumbly product that the farmer composts and land applies. And you can see here it's about 30% dry matter and about 70% moisture. And this is, again, a very common technology found on a lot of farms. This is our ultrafiltration system. So it is, again, a tubular cross-flow filter. We're circulating the manure inside the tubes. The liquid fills the shell, and then the permeate comes up the top through this sight glass. So this is a picture up close what it looks like. Again, sort of a filtered beer look to it. So there's no solids. It's transparent. You can see through it, but obviously it has color. And then this is just a picture of the tube sheet. So basically, if you cut open our ultrafilter and look down it, each of these holes you see is the opening to a 10-foot length of that 3/4-inch pipe. So basically, we're pumping manure through a lot of pipes in parallel, each of them providing filtration. And this system, like I mentioned, it's been, it's actually, this presentation is a little out of date. It's over 1,000 days. And so we have a lot of good experience with a lot of data, and we think it's a very robust solution for this application. A little bit of data just to back that up, both from Majestic and from other farms. This was a 70% permeate recovery. So 100 gallons of digested manure became 70 gallons of permeate, 30 of concentrate. And you can see here that the digested manure was 4.4% solids or dry matter. The permeate was about 1.5% solids, and those are all the dissolved solids. Those are all the salts and any soluble organic matter. And then the concentrate was 10% solids. And that is a very nice concentration factor. And again, so you have a thickened slurry with all the phosphorus. And you'll see here on the phosphorus line, the P2O5, we came in at 11.8 pounds per 1,000 gallons. The permeate had 0.2. So that's over a 98% removal of phosphorus, which is, as far as we're aware, the most efficient phosphorus filter available now for manure. I'll just mention quickly that we were involved in the Vermont Phosphorus Innovation Challenge, and part of that work was to show that indeed our ultrafilter does remove phosphorus from manure, and we can help concentrate all the phosphorus from a farm into, again, about 20 to 30% of the volume. And then if we handle that volume more responsibly, we've done a lot to help phosphorus from contaminating watersheds. And so one way we do that is we transport the phosphorus-rich concentrate to a composter. And he can top dress piles with it. He can incorporate it into different recipes. And so we actually did this. We created a recipe that involved some of the fiber from the screw press, some of the ultrafilter concentrate, and then some wood chips. And the composter was very impressed. We made a product that had about twice the nutrient content. You can read our full report through the VPIC program. And that's a program that we are helping to roll out in Vermont to create a hub and spoke model where you have a hub as a composting site, and then you have spokes of farms that have ultrafilters, and you can bring the UF concentrate from these satellite farms to the hub to be composted. And then once it's in a stabilized composted form, it can be either used more responsibly in the watershed, where farmers still do need some phosphorus nutrition for their fields, or it can be exported out of the watershed where it's no longer a risk to contaminate the nearby waterways. All right, so that's the ultrafiltration component. Once that material has been ultrafiltered, now it's time to suck as much water out of it as we can using our forward osmosis system. So this is a 5-stack system you see here on the left. And basically we are circulating the ultrafilter permeate through those stacks on one side of the membrane, and we're circulating salt water on the other side of the membrane. So on the right, you can see what that usually looks like. We have UF permeate on the left. This is the FO concentrate, so that's the dewatered UF permeate, and then we have the clean water that the cows are drinking on the right. And I'll mention that the FO concentrate, again, is an ideal liquid fertilizer certified for organic use. A little bit of data on that. We can make about a 5% solids FO concentrate. Again, these are all dissolved solids, and it'll be about 35 pounds of nitrogen and about 48 to 50 pounds of potassium. So again, it's a high nitrogen, high potassium product, and our water is clean enough to discharge and clean enough to feed back to animals. So we're actually one of the first groups to get a discharge permit to put water reclaimed from manure into a waterway in Wisconsin under an NPDES permit. And since then, there have been several other applicants that have sort of gone through the same process. But a couple of years ago when we did that, we sort of paved the way for that to become more commonplace, and we think that is a good option for farmers, but we do also encourage them to think about how to reuse that water on site, whether it's feeding animals or using it for irrigation in a dry year and increasing their crop yields. Like I said, our systems are fully automated. So we have this is a picture showing an automation screen at the farm. We have an online system we call Biometrics, where the farmer or the user can log in and see how many gallons of water it made today, how many how the filter was performing. So we try to make it very user friendly and very intuitive, so it's not an extra burden on the site. We do a lot of piloting for new potential customers and for new applications. So all the time people call us and say, hey, I've got a mix of swine manure and dairy manure, or I've got swine manure plus food waste, or I've got digested food waste, or any kind of unique stream. And sometimes we can say, oh, we've done that, here's what we think it's going to look like. Other times we say, you should really send us 30 gallons in some buckets, and we'll run it on this small scale equipment first. We can show you what it looks like from a visually, as well as do analytical assessment of the various the feed stream, the permeate, the concentrates, and then we can size equipment from that. So that's always something I like to point out to people, is that our equipment is very scalable. So we can show up to your site, and on the right here is a picture of Ian doing some work on a rental unit that was at a customer's location, where it was running for several months to demonstrate how the process works for them. So we like to be able to demonstrate our process at a small scale to both educate our customers about how it works, and also to collect data so that when we scale up, we have the appropriate size equipment. So kind of just to summarize, we think we have one of the only integrated solutions for going all the way from a wastewater like manure to clean dischargeable water with a non-biological system. So you'll notice I didn't talk about adding additional digesters or aerobic treatment systems or anything else. So this is just unique filtration solutions paired together to create an integrated package. We have relatively low operating costs, and I'll talk a little bit more about that. I think that is competitive typically with the cost that most farmers have for land application of manure. We can do a lot to eliminate lagoon management challenges. So if you talk to a dairy farmer, a lot of them will say, one of the things that keeps them up at night is their lagoon filling up. And if they get a big rain, it could overflow. They have to deal with tightening regulations about when they can apply, which lands they can apply to. They tend to sort of fight over the same trucks. Like when it's a nice dry day and everyone's trying to spread manure, everyone's calling the same guys to come run their trucks. So it's just it provides, or it causes a lot of anxiety. And if you had a system that was constantly turning your manure into water, you could choose to put manure nutrients on your fields and on your crops when your crops needed them, and not when you were stressed about your lagoon being full, which is what happens a lot. A lot of the runoff that causes contamination of, like the lakes in Wisconsin, for example, is because farmers are forced to apply manure to frozen land, or during times of year when it's not appropriate for the crop, but it's their lagoons are full and they have to do it. Or the weather is poor and they spread, and then it rains a lot. And if they weren't stressed about their lagoon level, they wouldn't necessarily have to do that. Not as much in the Midwest are people that worried about conserving fresh water, but certainly out west in our country, where droughts are more common, the ability to recycle water on site, I think, is a huge advantage, and would minimize stress on wells. Like I mentioned, our technology is very scalable, so I can do a system for a 200-head dairy farm or a 10,000-head dairy farm, and they both I think can be pretty effective. Again, with a concentrated product, we do provide the ability to kind of target nutrients, so we can improve crop uptake and apply it when the crop needs it. Again, we didn't add any polymers, so we're making organic products, and we're highly automated. And something we're still working towards more and more is how do we help farmers that choose technology like this to get some kind of a branding boost, or some kind of public perception about choosing, for example, like choosing milk from dairy farms that sustainably manage their manure. And if there was a benefit for that, that would incentivize farmers to install technology like this, we're hoping to find partners that can help us develop that. A little bit just on pricing. People always ask, well, what does this cost? So I try to put together some kind of ballpark numbers on like a per cow basis. So again, if you're talking about swine or other animals, this isn't going to be super applicable, but obviously you could always reach out to us and we'd be happy to provide budgetary information. But in general, this gives you kind of a breakdown on a per cow capital cost and operating cost. And if you convert that into cents per gallon, I typically tell people I can take a gallon of manure and turn it into a gallon of water for about 1.5 to 2 cents per gallon of water, assuming typical sort of like average electricity rates, average operator costs, things like that. So that's and most farmers in Wisconsin right now, unless they're kind of in a unique situation, would say they spend 2 to 3 cents per gallon hauling material out of their lagoon. So if I can make a gallon of water for 2 cents and I have all these ancillary benefits of lagoon management and less soil compaction and fewer trucks on the road, we think we have a very interesting and compelling solution. On the leachate side, I would say it's even more compelling. So if you have a big farm and a lot of leachate and you're being forced to put that in your manure lagoon, we can make water even less expensively. And we're also working with certain partners to offer infrastructure as a service. So some groups will want to buy the system and own and operate it. Some groups will not want to buy it. They'll want to pay per gallon. And so we can help finance that as well as like a lease type approach. Finally, just a couple other, I feel like I'm talking about a manure for 20 minutes, just a couple other pictures to show you what our ultrafilter can do with other things. So on the top left is a potato chip manufacturer we did some work for, showing they were paying about $100,000 a month to put raw wastewater into the sewer. And instead, we could filter out a lot of the contaminants to reduce their disposal costs. So then we put the UF permeate in the sewer, and the UF concentrate was a high starch product that they could sell to someone who was making vodka. So it's kind of a nice way, again, to reclaim that waste, turn it into something useful, and simultaneously significantly reduce costs. Sort of a similar story with the carrot processor. They were putting raw wastewater into a lagoon and trying to land apply it. We could make a filtrate that they could reuse to actually wash carrots with, and then a concentrate that was an animal feed, and they were shipping to a nearby dairy that was feeding it to cows. This is on the right, top right is a biodiesel corn oil washing wastewater that was very challenging to treat and very expensive to sewer. And we were able to clean that up, giving them reusable water. There's still some color to it, but it was reusable for washing. And then a concentrate that was very high in fat and was sold as an animal feed. On the bottom left is a distillery. So, a distillery grinds up grains, ferments it, makes alcohol, evaporates the alcohol, and you're left with the stillage, which is the spent grains. Those get, here we're filtering those, and we're making a concentrate for animal feed, and then recycling water back to the distillery. So he has significantly fewer trucks hauling stillage off his property. And then at the bottom right is food waste digestate. So we're seeing more and more of this across the country as interest around food waste and climate change has grown. People are digesting food waste, and it's the business model around that. The operators of these digesters are making most of their money collecting the material. So they're collecting a tip fee at the gate, they're selling some gas, and then they're left with all this digestate, and it's their number one cost. It's like, what do we do with all this digestate? And so we can help them filter that, both using our UF and our two-step RO, and put most of that water into a nearby stream, let's say, or even into a sewer, and then a concentrated fertilizer could be sold to nearby farmers or marketed more widely. So that's a little bit about what we do. Again, my name is Bobby Levine. My contact information is here on the screen. My email is robert.levine@digestedorganics.com. And I would love to talk to anybody who happens to be listening about any projects you might have that could benefit from this kind of technology, or any kind of strategic partnership you might be interested in. So I'll leave it at that and happy to take any questions.
Awesome. Well, thanks for walking us through the presentation, Bobby. For the audience, to ask a question, you can use the hand raising icon and I'll unmute you. You can ask your question over the voice prompt, or you can go to the question window on the right side of your screen and type into the question box window. So I'll start things off with a few questions of my own. Bobby, first off, really impressive work you guys are doing, helping us build a more sustainable future. We want to give you credit for that. One of the things that I noticed as we were walking through some of the slides, more specifically depicting your technology, it seems like there may be a lot of upfront infrastructure costs that may be kind of steep. So I was just curious if you could kind of talk a little bit more about what are the key components of the digested organic system, how much that costs from a capital standpoint, how much that costs to install, and then ultimately what the payback period looks like that for a variety of different businesses that might be interested in such a product.
Yeah, it's a great question. So the key three technologies that we actually manufacture and sell are going to be that spiral filter, the stainless steel ultrafilter, and the two-step reverse osmosis system, which combines the forward and reverse osmosis technologies. So we can apply those, again, to manure, to food and beverage wastewater, to all kinds of different streams, but those are the three technologies that we specialize in and then kind of tailor to specific projects. And in terms of cost, so they sort of get more expensive as the filtration gets finer. So the spiral is the least expensive, the ultrafilter is sort of in the middle, and then the two-step RO is just a little bit more expensive as we're trying to take a wastewater all the way to clean drinking quality water. So I can't really give a specific price range because it's very specific to the material being filtered, because different materials filter at different rates, and then different projects have different sizes. So one farm might have 100,000 gallons a day of manure and another might only have 10. So it is pretty custom sized, but I would say the projects where we've been successful at, I think do have a very reasonable ROI. So probably in the ballpark of 2 to 3 years, for the purchaser. And then, the operating costs are ideally less than the site is experiencing today, plus a lot of ancillary benefits. I will say, especially working with farmers, it's hard sometimes to quantify a lot of those ancillary benefits. Like if you can take half of your trucks off the road, like what's that worth to you besides the 2 cents per gallon? Is it like the less wear and tear on the roads, the fewer neighbors complaining, the less chance for accidents, less wear and tear on your equipment, less operator time, that guy can do something else? I mean, there's same thing with like less soil compaction if you're applying fewer gallons, better crop uptake of nutrients. So there's a lot of these things are hard to quantify in like a sort of a simple ROI model. So I would say a lot of farmers we talk to actually just sort of want to break even. So if they are currently, let's say, hauling manure at 2 cents a gallon, and they know how many gallons they have, and they think they can put our system in, and with the combination of the operating costs and the capital costs be at the same 2 cents per gallon, like the same total annual bill for managing their manure, but they're going to have all these ancillary benefits, that is a win. So sometimes it's not even a conversation about ROI, it's a conversation about how do I keep my costs the same, but get all these benefits, get better. Now I have 2 concentrated fertilizers, which I can use very uniquely compared to raw manure. And so that is that's sometimes sort of more the focus of the conversation.
Okay, gotcha. Thanks for walking us through that. That actually, I think, touches upon my next question, which is trying to think about this quantified value. It sounds like there's maybe not a clear-cut answer to this, but you guys have done a really good job, I think, of developing a technology that's widely applicable across numerous different use cases, across numerous different industries. So I guess my question here would be, what specific use case do you think, if there's a potential customer listening to this presentation, either now or on replay, where it's like applying this technology to their business would be a no-brainer in terms of ROI, in terms of the other benefits that you just mentioned, whether that be from a branding standpoint or a production of byproducts that were otherwise waste and are now additional revenue streams, reduction of wastewater. What specific use case do you think leads to the ultimate value? And in that scenario,
Sure.
A potential interested customer definitely reach out.
Yeah, I think there's a couple that kind of pop to mind right away. So I think if you're a large dairy or swine farmer and you're paying somewhere between 1.5 and 3 cents per gallon to get your manure out of a lagoon onto your land, I think we should be talking about how we can turn your manure into water and concentrated fertilizers. Like, I think we're at that, like, we're competitive with those typical prices, and that's what we hear from a lot of the big farmers right now, at least in the Midwest. So I think that's one obvious use case. I think the other is the leachate. That's, these big farms have, tens of thousands of gallons a day on average of leachate, and we can very cost effectively treat that compared to that, 1.5 to 3 cents per gallon. So I think that's a very interesting use case as well. And then thinking a little bit more industrially, if you have any kind of hot, oily wastewater, whether it's at a biodiesel plant or a food and beverage stream that has a lot of oils in it, that's something that our Ultrafilter is very uniquely suited to. So it can handle hot materials, it can handle oily materials, it can handle high solids materials. So if you have any of those three things, compared to other filtration approaches, our stainless steel filter can really excel at those. And just one example is, like, we just are installing a system at a distillery in Kentucky called Wilderness Trail, and they're sending us 90,000 gallons a day of stillage at 190 degrees Fahrenheit, which pretty much would melt every other kind of ultrafilter that's made of some kind of a polymer or plastic, like a PVDF or other common materials. So it's a fluid that's very high solids, very hot, and relatively abrasive, and our stainless material can really excel at that food and beverage product in a way that few other products could. So I think that's another example where if it's hot, it's oily, and it's full of solids, we're going to do a really good job filtering that, and can provide a very compelling return on investment, I think, for those users.
Yeah, awesome. Thanks for that answer. And now, lastly, what else can the audience help you with there? How can they find you if they want to get in touch? What are some of the other ways you're looking to develop relationships? Could you just, provide a little bit more summary here at the end of the presentation?
Sure. So, one of the best ways is to either go through our website and fill out our contact form, or learn more about our products there. We're actually about to be launching a new website in a couple of weeks, but the one that's up certainly works. My email here, at Robert Levine at digestatorganics.com is a great way to reach me, or my phone number here as well, to reach out to me directly. I would say we're a relatively small company. We have about 12 employees. We're based in Farmington Hills, Michigan. And I think we pride ourselves in giving our customers a lot of personalized attention that you wouldn't necessarily get from a much bigger company. So we can move very quickly. We can deploy pilots. We can work with you on a very individual basis to develop a custom solution for your facility. So I think that's something we like to do, and we do pretty well. And then I would say, in terms of other people potentially listening, like, we're always looking for partners that could either integrate our technology with maybe something else they're doing. So, maybe they're making some other kind of fertilizer product, and they could, utilize our filter, or anything else that we can kind of plug our know-how and technology into. We'd obviously love to learn from some new partners. And then, I do think one opportunity that we've talked about at the Manure Challenge as well is, like, how do we provide incentives for farmers to adopt sustainable technologies, especially around their manure. And so anyone that has ideas about that, I'd love to talk to more. And I think, building a community around more sustainable manure management, and trying to learn about how we can help farmers, help our watersheds, and help our communities, and incentivize them to do that through some kind of probably financial means, or some kind of branding, would be great. So I think that's definitely part of the bigger picture on how we get manure more sustainably processed, and we'd love to be part of that conversation.
Yeah, makes sense. Well, thanks for your time today, Bobby. Definitely appreciate it. And thank you, everyone else, for listening and participating in the webinar. If you'd like to learn more about digested organics, please let us know by answering this poll question. We host these calls every week at 3 p.m. Central. You can register for Agrifood Conversations by going to agrifoodconversations.com. A replay of this webinar will be emailed to you in the next 24 hours. And if you know of others that may want to see this webinar in replay, they will be able to access it on agrifoodconversations.com within 24 hours. Thanks for your time today, everyone. Enjoy the rest of your Thursday.
Thank you.